Hey there, welcome back to Coding at Home. Hey there, welcome back to Coding at Home with the Code Hub. I'm Matt with the Code Hub. Today we are going to continue our journey in Swan's Quest. Hopefully you're keeping up. If not, nothing to worry about. These are fairly advanced playgrounds. They're designed for the attendees at WWDC who are nearly all professional developers, so they're well used to Swift at this stage, and it's providing an extra challenge for them. We can see that because there's not a lot of instruction with the actual playgrounds themselves. It's basically a command saying run this code. There's some instructions as we get going inside the actual playground from the lizard or from the swan, but we're really left a lot on our own, and we're getting introduced to some really interesting new concepts. And today, with Chapter 3, is no different. And I'm guessing the same thing is going to be true tonight when Chapter 4 comes out. There's going to be new concepts that we have to work with. So, the first day we covered voiceover, which I thought was amazing. We learned how to add accessibility hints and accessibility labels to different torches, and that lit our way through the cave. We got that first scroll with the numbers on it. They turned out to be frequencies of notes. This is where I started to get a little bit lost, as I'm not super musical, as many of you will know. And in Chapter 2, we used those notes to play tones. And we played tones in through this class called the tone output. That would actually use the audio system to play out that particular frequency that we had entered in. And doing that, we were able to play a certain scale, and then and we were off and running. We got the next scroll, which was some sheet music. So if you watched the video, if you haven't yet, no big deal. I tried doing it this way, where I didn't watch the video and I tried to complete the task. You definitely need the help from the guys, because they'll explain to you a little bit about the music theory behind the code that you're writing. So with that, we're going to jump right in to Swan's Quest Chapter 3, with a quick detour first to show you another playground they showed off yesterday that I also put in the WWDC feed you can grab, called Colorquest. So we'll take a look at that first, and if you want to spend most of your time playing with that and maybe listen to me talk through the other stuff, that's cool, that works. Otherwise, you can take a look at it, say, yep, that's great, I'll come back to that later, and we'll move on to Chapter 3. All right, so let's go over to the iPad. All right, we'll make sure the volume's on so we can hear ourselves again. So if you've grabbed the feed, at this stage, hopefully you have, it's down at the bottom of all mine, down here. So we have a whole bunch more playgrounds. Now we have the blank Quest Create template. That's not the one we're going to be playing with today. We've done Chapter 1, we've done Chapter 2, we have Chapter 3, and then this one over here, Colorquest. So if we tap Get on Colorquest, we're just going to take a look at this first. They demonstrated this to show off how you can author playgrounds for both the Mac version of Swift Playgrounds and the iPad version, and how you can add differences to those things between the Mac and the iPad. Because obviously on the Mac, you can't do augmented reality, but you can on the iPad. All right, so I have this copy. This is what Colorquest looks like. So I'm going to tap on it. Comes from a third party. I'm going to say, yep, I want to open it. So there's a little bit more instruction here. This maybe looks a little more familiar. We can look in this file called Turtle Edits. So if we tap up here, we'll see the files. There's an AR Turtle, Color Grid View, Turtle Descriptions. There's our Turtle Edits file. I'm going to tap on that. And it opens up a new tab for me. So I can see that there are a few different things, a few different functions I can call. So different turtles, turtle 3, merge colors, darken color, lighten color, change turtle skin. And that's what we're going to use. So in the instructions here, we start with change turtle skin. So if I tap to enter code, I can say, okay, let's go find in the autocomplete bar, I'm going to change turtle. You can see belly, eyes, skin. Let's change the turtle skin color to Maybe let's do a blue. How about that? That's all we're going to do for now. We'll hit run my code. Okay, all right. So you can see that the turtle skin has turned blue. Now we can also do that with the light color and the dark color on the back of the turtle. I can hit save. And this is going to ask me if I have permission, if I give permission to add this to photos, so it'll save it to photos. Now that functionality is all present on the Mac version of Playgrounds as well. And on the iPad, we have this extra AR button down here. So I'm going to tap on that. It's going to ask me for permission to access the camera. I'll say okay. And then we'll zoom around. Now I'm supposed to see the turtle. I've not actually had any success getting the turtle show up. So we'll have to debug that. But this is just something you can play around with. You can, in addition to changing the turtle skin, like I said, you can also change the dark area to, maybe let's make this turtle a bit psychedelic. Change the light area to maybe green. And then let's hit run our code to see what that turtle looks like. Okay, that's a little trippy. So we can customize our version of the hero for Swan's Quest. So that's the Colorquest playground. There's not a lot to it. This is kind of it. That's the only page, as you can see. There's a little bit of explanatory text. The AR stuff wasn't working. Maybe we can debug that next week. That might be kind of fun to dig through. But I just wanted to show you that because maybe you'll want to stick here and work on designing the color of your turtle. You can do that, and you can also play around with turtle edits and change stuff in there. You can see how they implemented actually drawing these blocks for the turtle. And a little bit of color work with RGB, red, green, blue values. So if that floats your boat, you can go over and play with that. Otherwise, what we're going to do is we're going to try out Chapter 3. So we're going to go see all. I'm going to go down to the very bottom, down to our WWDC playground or feed. I'm going to grab this Chapter 3, the notable quest, I think. No, the notable scroll. So we'll hit get. All right, and when that downloads, we're just going to open that one up. We are going to say, yep, we're okay opening it, even though it came from a third party. All right, and we have some brand new things right away when we open up this playground. We have some brand new things in front of us here. We're in the Music.swift file, which has a whole bunch of stuff. It has this public protocol pitch protocol. It includes a property declaration of frequency, and it's a double. And then there's this weird get inside the middle. There's another public protocol, node protocol, with an associated type of pitch protocol. There's some other properties defined here, like tone, length, shortest supported note length, subdivide. There's a public enum note. Now enum is another new thing that we haven't seen before, where we have these different cases, and one case is quarter, one case is half, and then it has a property called tone, and the tone will return. Right now the tone just returns a tone of pitch 440 with a volume of 0.3. So this is where we get into music theory a little bit, and this is where I'm probably not your best guide for this particular mission. I highly recommend watching the video because the video makes a lot more sense. The guys do a good job of explaining music theory and maybe how we have to structure our objects. Because again, these protocols and enums that I'm going to explain in a bit, in just a second, it's all about organizing our code. Again, there's loads of ways we could have solved this quest or written our code to do what we're trying to do, which is play some musical notes. And this just happens to be one way of organizing it. Now, the Apple engineers usually organize things pretty well, so it's worth following their example. And we have some notes in here that say fix me placeholder, so we can guess that this is where we're going to need to make changes to actually get this playground to run. So we have the shortest supported note length. And then we have a subdivide method here, where we're going to get back an array of pitches. And then we have another enum down here called pitch, and it's of type double, and it implements the pitch protocol. So we can see somebody's defined a bunch of cases, thank goodness, of frequencies for the different notes. So C3 is 261.63 and so on. And it tells us down here, this is the sonic frequency of this pitch. So when you have a pitch like C3, you can actually use dot notation to access the frequency of that particular pitch. And what it'll do is it should return this value or this value. If you have a C3 pitch, it should return 261.63 because we're going to use that to feed that tone output class that we used before. And you can see down here that we have a placeholder because this is just returning 0. Now this is a lot of code and a lot of brand new concepts. So let me just explain to you why you might use a protocol. Protocols in Swift are a way of you, the developer, or Apple developer, or some other developer, of defining how a certain thing is going to look and behave. It's a little bit like a superclass, but anything can implement a protocol. Whereas when you have a superclass, you all of a sudden have a hierarchy, so it looks like a tree that branches out. So the very trunk of the tree would be maybe the animal superclass. And then a branch out to one side would be a dog subclass. And a branch out to the other side would be a cat subclass. And another branch would be a horse subclass. So they can't jump from branch to branch and rejoin. But you might have protocols that can be applied to any class. So I might say, you know what? I just want, when I use the print function that we've used before, to print some information out to the screen or to the console, most objects implement this describable protocol, or custom string convertible is the real name for it. And basically that says that, hey, anything that implements this protocol is going to have a property on it called description. So when I call that description method, or that property, it's going to give me back a string representation of that object. So basically just some text about the object. A little bit like our accessibility hints. We would write a custom description for our types. So like if we had a type for byte, remember that's how we got introduced to types in the first place. If our character type implemented this describable protocol, we'd be able to say, hey, give me your description. And we could, in that character that we have, we could actually provide our own description. So it's a fairly advanced thing. We use it a lot when we do user interface programming for the Mac. And we'll see it a lot when we get into things like app development with Swift. And enum is another way of organizing our code. Like this is actually a great use down here of this pitch, where we don't want people to define just any old number for the frequency they want to play. We want to align them to a certain scale. So we've actually provided the frequency values and we've given them handy names. So if you're studying music at all, these will make a bit of sense to you and you'll be able to say, oh yeah, okay, I want the pitch for F3. All right, so let's go back here. We have nothing going on right here. We just have a to-do saying define 3 quarter notes in the array below. Well, let's try doing that before we hit run our code. We're going to tap on these braces here. Our little 2 dots come up. We're going to tap on add item. And so to define a quarter note, we can tap on note down here. We'll hit the dot. And we have these 2 methods here defined, half pitch and quarter pitch. So we're going to define 3 quarter notes. So we'll do quarter. Now pitch is an enum. So enums you typically access by doing something like this. Pitch, dot. And you can see in autocomplete, it shows me all the types of pitches we defined in that pitch enum. So let's just play A4, and then we're done. This is our quarter note using the pitch A4. Again, I am definitely not your musical guide, so heaven help you all. I would definitely watch the video to get more information on the theory behind this and some more insight into the music theory behind all of this. Let's add another note. So we'll type in note, dot, quarter, and then the pitch we're going to use. We actually don't have to type out pitch. Swift is smart enough that it'll say, look, I know that you want to access something on pitch. So you can just use the dot, and I'll give you these autocomplete options. So I'm going to pick B4. And then I'm going to hit the end here to add another item. And we'll do note, dot, quarter. We can hit the dot again and hit C3. Okay, so that's our to-do, and we've done it. We've defined 3 quarter notes in the array below. We have note.quarter and then pitch A4. In fact, you know what? I'm going to delete that pitch just to make it all consistent. So now it has note.quarter, dot A4, note.quarter, dot B4, and then note.quarter, dot C3. All of these note, this note type and this quarter function, they're all defined in this music file. So if I go here, see, here we have our enum that's a note, and there are a few different types of notes. So quarter, half, I think we'll probably have to add eighth before we're done with the WWDC sessions. We return a tone. Now this is fixed right now, so we need to address that. Let's go back to main. So you should have an array that looks a bit like this. I'm going to hit run my code. We'll press play. All right, there we go. We hand the lizard the new scroll. We go to next. Now, the first thing the lizard notices is that the notes are of different lengths. So we can see that we have, oh dear. Well, I think it's, this one is a half note. These are all quarters. I could be talking complete nonsense, probably. And there's a dotted one. There's something special about that as well. So here he mentions that there are quarter notes and half notes. So to get started, we need to build a note type that conforms to note protocol. Well, someone's already done that in the Music.swift file. So look in Music.swift and you'll see he's already started an implementation for us. We need to add a case to our enum for quarter notes to get started. Well, someone's already done that as well, actually, because if we look at music, it's already defined there. We have a case quarter pitch and case half pitch. So we're ahead of the game. So now we need to complete pitch. So pitch was down here. Here's the note enum in Music.swift. Now we need to complete the pitch one. So we'll need to add cases for each note in the scroll like so. Well, someone's actually done that for us as well. Great, we're way ahead of the game. So we can use our timer from the last challenge by subdividing notes into pitches. Okay, all right. This let pitches equals notes dot subdivide. All right. Well, that we'll I guess we'll get to that. This is where I got a little bit lost yesterday because I was not 100% sure what that meant from a musical standpoint. So he's telling us that we can calculate the timer interval using note shortest supported note length and multiply it by the duration of your quarter note. So it's sounding a little bit like Greek at this stage. It definitely helps to watch the video as the guys walk through how they intend for this to work, how they intend for this music library, basically, because it's kind of what it is. It's code someone else has written for us to use, but it's to see how it works. All right, so we calculate the timer interval using note shortest supported note length. And then he says, finally, don't forget to call end performance when we finish playing the tune. This lets Swan know you're done so our revisers can judge your performance. Well, if I hit next, it says, let's make sure your note and pitch implementation works. Add 3 quarter notes to the notes variable I created. We did that. If we hit next, we hear nothing because we're not playing it. We don't have a tone output to play anything. So if you go off to the developer app, so I'm going to exit out of that, open up the developer app, I'm going to close this video. This is the video. And we've got, so I went off to take Swift Playgrounds to the next level, explore Swan's Quest, Swan's Quest Chapter 3, the notable scroll. You can search for this as well. So when I tap on this, I get, again, my 3 tabs, overview, transcript, and code. And we have, again, links off to the forums, the Quest Create Playground book, the Swan's Quest Playground, the developer forums for Swan's Quest, and some related sessions. We have transcript, and then we have code. Well, the code kind of explains a little bit, because they have it up on screen, some of these elements that we already have. This is how we work through updating the time interval. So we have a new variable called interval, and it's of type time interval. And we use this note shortest supported note length times a half, and then a note of 120 beats per minute. And then we use that time interval inside the timer. That's really the only thing that I cared about out of this. Because I wasn't 100% sure how we were correlating it to 120 beats per minute, but we're just going with it. So when we scheduled the timer, instead of using 400 every 400 milliseconds we'd fire, we now fire according to the length of the note we're supposed to play. So that the tone output will keep playing that note until the timer says, "Oh, yep, cool. Enough time has passed." Whether it's a second or half a second, and then it'll go run the next one. So it'll replace the tone that's playing with the next tone that we're supposed to play. So the rest of the code looks kind of similar to the stuff that we've done in the past. We still have this guard index. We're looking at the tones. We end the performance if we're at the very end of the tones array. We play the tone at that tone index, and then we increment it by 1. So this is playing more than one tone. This is the code basically that we wrote for the Swan's Quest Chapter 2. Then we have this update, so adding subdivide to the note protocol. So that's there, this function subdivide. And they have comments, which are good. So subdivide into a series of pitches according to the shortest supported note. Okay, and this is a little bit like Greek, and if it's a little bit like Greek to you, that's okay. The way that I solved this last night was I just monkeyed around with it, especially this part here. This is roughly what we're going to add to our main.swift file. We'll have a tone output. We'll have our notes You know, and this is just like we've done. We've added an array of, well, this has actually got a half note in there as well. We say that we're going to have an array of pitches. So we actually use that subdivide function to get pitches out and add them to this array. And instead of using the notes array to loop through, now we're using the pitches because we've tried to even things out across the timer. So the timer will fire every, say, 1 second. Well, some notes are going to have to play for 2 seconds, and some are just going to play for 1. So if we have to play a note for 2 seconds, we use that subdivide method to get effectively 2 instances of that note, or at least the pitch from that note. So that's roughly how this works. This may still sound like Greek to you. Don't worry, it still sounded like Greek to me. So what I did was I went back and I grabbed the code that we had in the Swan's Quest 2 playground and copied it over. So let's go back to Swift Playgrounds. And what I'll do is I'll actually post this code in the description of this video so that if you want to try it out while you're watching along, you can copy and paste this code in so you can just get through Swan's Quest 3 anyway. So this is all fresh. Let's close out of this. This is the one I was working on yesterday, this completed one. So we're going to go back to the advice from the lizard. Now you can see I start out in the music tab. I'm going to tap on the main Swift file. I have my notes, my quarter notes. I started off by trying to include it in a performance function because I thought that we still needed the performance function for when we were talking to the lizard. It turns out we don't. So what I did was here, I'm going to copy this from here. We'll select, whoops, not all. Here, we'll go back up here. We're going to select not all, just a bit, and then we're going to go copy all of this stuff here. We'll copy that. So what we're going to do with this code is I've copied it. I'm going to go back to the other playground. So we'll close it down by hitting the X. You don't have that one, obviously. So here we'll open up the one that we were working on. And we'll walk through the code that I'm going to add here. All right, we open up the music one again. Let's go tap on that. We have our notes defined. So below there, we're just going to paste that other code. We have our tone output that's actually going to play the sound. We have, I should take out that to do because this is the performance here. We have a note index. We have a scheduled timer that goes every 0.4 of a second. We have our guard from the other day. And we just play all the tones, all the notes. So let's try running this and see if we get past the lizard's check. So you can hear that because it's not in a performance function, it actually played the tone immediately. So we talk to the lizard again. They tell us about the code that they've written. They talk to us about Subdivide a little bit. And we don't pass. Let's see, we did pass on the other one, so what is the deal? Let's go back to completed and check it out. There's our oh, you know what? We had to update some of this stuff in here, I believe. Okay, so what we had to do was, because we're returning a pitch frequency of 0, I think, and a length of less than 1, we had to fill in some of these items here too. So tell you what, we're going to actually copy and paste over this entire music file. This is where I wasn't 100% sure we were going to do this playground today because it's not super useful for you to watch me cut and paste stuff. What we'll do though is we'll have links off to the actual code that we've written here. So let's select all, and we're just going to replace this entire chunk of code. It's not super useful to watch someone just cut and paste stuff. So we have this self.raw value is what we return from frequency now instead of 0. We've implemented the subdivide method. So you remember I talked briefly about a half note is going to play twice as long as a quarter note. So where we only need one pitch from the quarter note, we need 2 from the half note. We get the shortest supported note length. We just ask for the length of just any old quarter note. Here's where we figure out the length of the different notes. So a quarter note, we kind of baseline at 1. For a half, we baseline it at 2 times 1. And we return different tones in these cases for our note enum. So let's try running our code and see if this works for the lizard. Okay, we had all of our different, you could hear the tones there actually. That it played different notes there. So if I hit play, we'll go talk to the lizard again. He'll tell us about the stuff he's written. So because I had to just copy and paste a bunch of stuff that I wrote last night, it's not super useful. But I also didn't want to lose you. So because we played those different notes in the beginning, the lizard tells us we're natural. Good luck, we're going to go talk to the swan. So if we go to the next page, now our music file is the same because remember this is a shared file, so all my changes are still in there. We have our half note defined, we have the length defined, shortest supported note length. So really all we need to do is change our code here. So the lizard decoded the sheet music in case we need it. So Q is for quarter note, H is for half note. The way it plays is we want our pitches to go E3, E3, F3, G3, G3, F3, E3, D3, and then down to the next line. That's how we're going to play the notes in order. It's the same thing as before. We code our performance here, and then we call end performance at the end. Let's close out. I'm going to open up the completed version, and we'll just have a quick look at that. Again, I apologize for doing this nasty bait and switch trick. This is awful. I hate when it happens to me, when someone kind of shows me a bit of code that they've already pre-written during a little tutorial. I swear I'll give you your money back. So this is the code. It looks very like we had last time. It looks very like the code Steven showed in the video. We're using the pitches index to get out the frequency to play that. We have our scheduled timer with the time interval that we've calculated based on the note's shortest supported note length times a half. We have all of our notes. We turned all of these things up here into notes and put them in an array. We created an empty pitches array and we looped through the notes with a for-in loop. And we subdivided the note. Again, I'm so sorry. So what we're going to do is we'll just select all, copy this. We're going to go back out to the previous one. I'll paste all this code up there so you can play around with it because I think that would be useful to be able to play around with it. We're going to select all here. Paste it in. Let's run our code. And what this highlights to me is that maybe what we need to do is give the Sonic Workshop playgrounds a chance. So I think what we might do after we finish off the last little bit of augmented reality we were playing around with is go back to the Sonic Workshop playground and try that one out next. So now we're talking to the swan, Trust the old lizard was able to help. So here we go. It's a tune that has a lot of meaning for the swan. So are we ready to start? Here we go. So we did it. We did it, sort of. We managed to get it to play and the tones to play at the right length and everything. It's a bit of work. The final challenge is going to be different and more complicated than the first two. Good luck to us for the next day. I don't know if we'll post the lesson tomorrow. Probably not. We'll probably do one on Monday. These are the notes that we're going to have to try to play the next time we meet the swan. So I have a feeling we're going to be expanding on those enums that we've created, the pitch and the note enum. And we'll see how we get on. So there we go. Off we go. Back with our little box. To be continued this evening at 6 Irish time. I know that was a lot. I know there was a lot of hand wavy stuff saying, and then we do this, and when we add this other magic thing, and then we paste in some code that we'd pre-written. I think it's entertaining to go through these playgrounds. I think they're designed for engineers who are at WWDC and maybe not folks like us who are going through the Everyone Can Code puzzles and all the other playground challenges. I think it's a good exercise because we're learning how other people organize their code. We're learning a little bit about other domains that I certainly don't know anything about. But yeah, we'll kind of keep going. We'll plow through Swan's Quest. We'll try to get through the last one, whatever is in the last one. And we'll just enjoy some of those lessons. I really think that Swan's Quest Chapter 1 was fantastic. I really love the fact that we looked into accessibility. And then there's been a lot of sessions where they talk about exciting features in Swift Playgrounds that we can take advantage of. So I know I'm hoping to, in my spare time, to get to some new playgrounds, and we'll have some more material to play with after we're all done with augmented reality, after we're done with Sonic Workshop. I hope you enjoyed today. Hope that was sort of helpful. I'll post all that code so that you can kind of take a look and try it out. And yeah, we'll see you the next time. We'll see you Monday. Please like and subscribe. That would be awesome. And we'll see you next week.